here. So the subject is AC machines 2 and topic is single phase induction motor. So now here, so objectives are, so double field revolving theory for starting starting for the induction motor. How to start the induction motor? So by this theory we can say, so we can start the induction motor. Now double field revolving theory, the state are given single phase supply, so only alternating flux produced. Here by given single phase supply only the alternating flux produced. So this alternating flux is resolved into two components. So here the two components are the forward flux and backward flux. So two components are forward flux and backward flux. So see here, so by observing this, so here the one magnetic field, here see this is showing one magnetic field and these are the two magnetic fields. Here this one magnetic field is showing how the pulsating will be produced. Here our two magnetic field, how this will be affecting two magnetic field, one magnetic field and two magnetic field. Here in double revolving field theory, so the forward flux and the backward flux are equal in magnitude, that is pi f is equal to pi b. Pi f means your flux in forward and pi b means the flux in backward. So now here the rotating in opposite direction at ns. These two fluxes are rotating in opposite direction at a synchronous speed. So here the flux, the pi f, that means forward flux in anti-clockwise direction and backward flux in clockwise direction. Pi r is the resultant of the forward flux and backward flux. Pi r is the resultant of forward flux and backward flux. See here revolving components of stator flux here. So see, observe this one. This is a, here in this, see here in this direction and this direction, two directions, 0 degrees, here minus 90, minus 180, or here minus 270, 0, or otherwise 0, 90, 180 and 270, 360. So this is a, so see here for the at the 0 degrees, see, observe this one, these are the directions is showing at this direction and this direction. Revolving components of stator flux here, see at this point. So here at figure B, here the, so see, observe this one at this point and this point. At, so in figure A at this, so A and B are at this side, and in figure C these are two opposite directions, and in figure D, see, observe this one, these are the directions are quite opposite, but see here, observe this one, these are the directions. And here and here the figure E, the figure E, the figure E, see here figure E, both are in at same point here at point E. See, observe this one. Observe this one. The double field revolving theory. Here, double field revolving theory. So here the forward and backward fluxes are forward and backward fluxes are forward and backward fluxes are of the maximum flux of the maximum flux. See the direction of here, this is the forward flux, and the direction is an anti-clockwise. The direction is anti-clockwise direction, and this is the backward flux. This is the backward flux. This flux is clockwise direction. This flux is clockwise direction. See here, this pi f and this pi b, these both are equal in magnitude. The direction is opposite, but the flux is equal in magnitude. Only the direction is different. So here, this is the pi f is equal pi b, that is equal pi 1 m by 2. The resultant flux in this case here, the resultant flux in this case is 0. So now, double field revolving theory, stator field and its two components see in the same direction they given here. Double field revolving the stator fields and its two components here, pi f and pi b. See here, these are in same directions, so we'll get pi r is equal to pi 1 m. In previous case, here these are in opposite direction, the pi r is 0. Why it is opposite direction? Quite opposite direction these are. In this direction, this one, it is in this direction. So here clockwise, and this is anti-clockwise. So now these are the stator field and its two components. This is stator field and rotor. Its stator field and its two components are same directions. The resultant will get a pi r is the maximum flux. Pi r is maximum flux. Now see here, in double revolving field theory, the alternating stator field, that is the field, it is varying with the time with the sinusoidal. This is the sinusoidal. See here, the flux is along the y-axis and the time is along the x-axis. Here it is starting from the 0 and 90 up to 90 degrees maximum, then it is 0. After that it is negative maximum, then it is goes on decreasing towards the 0 at 360 degrees. See here, in double field revolving, this is the alternating virginal field. So the resultant flux is alternating only but not rotating. So it is not rotating. This is alternating flux acting on stationary rotor. So here the rotor cannot rotate. The rotor is cannot rotate. So that is why a single phase induction motor is not self-starting. Here in double field revolving theory, the resultant flux is alternating flux, but here it is not rotating. This alternating flux acting on stationary rotor. It cannot rotate the rotor. That's why a single phase induction motor is not self-starting. So here in double field revolving theory, when the rotor is at rest position, here each flux produces its own torque. So here forward flux produces the forward torque and the backward flux produces the backward torque. So now pi f produces the Tf torque and pi b produces the Tb torque. That means backward torque. So Tf and Tb are equal but in opposite direction. Tf and Tb are equal but in opposite directions. So net torque is 0. So net torque is 0. So here for the double field revolving theory, torque speed curve for both the components and resultants. So speed in backward and speed in forward. Here 0 to minus ns and 0 to positive ns. Here torque is negative towards this one and torque is positive. Here this torque is due to backward field Tb, and this torque is this dotted torque is due to the forward field, and this torque is due to the backward field, and this thick line back line is showing that is the resultant torque. So here the resultant torque is the combination of Tb and Tf. Relative motion between the stator flux and the rotor is needed. So to create relative motion, rotor is given an initial start in either direction, then torque in that direction increases. So we giving the performance similar to three-phase induction motor. See, the relative motion between the stator flux and the rotor is needed. So to create relative motion, rotor is given an initial start in either direction. So then the torque is in the direction increases, giving the performance similar to three-phase induction motors. So see here the rotor rotating in stator poles, how it is rotating. At conclusion, at standard still, Tf and Tb are equal but opposite in directions. So net torque on rotor is 0. So single phase induction motor is not self-starting. When the rotor is given an initial start by some external means, resultant average torque increases in the direction of rotation. Motor gives performance similar to three-phase induction motor. Summary, we have discussed about double field revolving theory.